All right, we're going to look at example 3 and example 4 in our packet for skill 5B. So example 3 says find the amplitude and period of the function and sketch its graph. So looking at this equation, we do have our first negative out in front here, and then we have inside our parentheses 2x minus pi. So back when we filled in our templates for this, we need, this is what our template looks like. We have y equals, we have some a value out in front of whatever trig we're looking at, so it could be sine or cosine. Then we have our value for k in front of our parentheses. We have x plus or minus b, and then plus or minus d on the outside. So our a is our amplitude, k helps us find what our period is by doing 2 pi over k. This B tells us our phase shift. So is it going left, is it going right? And then the D tells us the vertical shift, so up or down. So something to notice about this template is that our K is outside of our parentheses, and then our coefficient of our variable X inside the parentheses has to be a positive 1. So looking at our example, the number in front of x is not positive 1. So what we need to do is actually factor out a 2 to make this a positive 1 in front of x and then see what ends up happening. So to factor out a 2, I'm dividing both of these terms inside my parentheses by 2, and I'm going to end up with my 2 in front of the parentheses. So I don't have a lot of room here, but I'm going to kind of do it, I'm going to rewrite it over there. So I still have my y equals negative cosine, so I keep that. But since I'm factoring my 2 out, because I'm dividing both of these by 2, I have 1, 2 outside my parentheses. When I divide this first term by 2, my 2's cancel. I get x by itself. I'm real close to the paperclip, so it keeps lifting. Then I have minus pi over 2. Well, that doesn't simplify, so I'm going to keep it as minus pi over 2. And then that was it. I don't have anything after my parentheses, so I can see my new equation here. And this is the equation that I want to work with. So from here, I can figure out my amplitude and my period. I don't have a space to write it, but my amplitude is the absolute value of my a, which is negative 1. So my amplitude will end up being 1. My period is 2 pi over 2, since this is my k, which would end up being pi. So now I can go ahead and get started. So I'm going to fill in this first column, and let me just turn this back. It says divide each x coordinate by k. So I want to divide everything by 2, since k was 2. Or I know that if I'm dividing by 2, that is the same thing as multiplying by 1/2, depending on whatever is easier given my x coordinates on the left. So my first x coordinate is 0. 0 divided by 2 still is 0. So that one doesn't change. Next I have pi over 2. Because this is already a fraction, I'm going to multiply by 1/2 because that's going to be easier for me. So I multiply straight across. So I get pi over 4. The next one, I could divide by 2 or multiply by 1/2. I get the same thing, pi over 2. Do want to put boxes around these. Then I have 3 pi over 2, and I'm going to multiply that by half. So I get 3 pi over 4. And then the last one, 2 pi divided by 2 or times 1/2 will get you the same thing. You get 2 pi over 2, which would simplify to be pi. So this first column is taking into account the transformation that this is causing, so our k. Now I want to move on to my phase shift because I do have something being added or subtracted inside my parentheses. If it is being subtracted inside my parentheses, I know that's actually going to the right, which means when I do the math for it, I'm going to add my pi over 2. So it's always the opposite. So I always cross off the one I'm not doing so that I remember in case I get distracted or I forget what I'm doing. I I won't mess up half of them. So when I fill in this column, I want to use my most recent x-coordinates, which were going to be these, because we turned these into these x-coordinates for our period change. So these x-coordinates reflect that. Then I want to take this and apply the phase shift, because when I graph the x-coordinates from here, I'm doing two transformations in one. So this x is 0, and I'm going to add on to that pi over 2, which would end up being pi over 2. Then I have pi over 4, and I want to add on to that pi over 2. Well, I don't have common denominators, so I want to make common denominators. So I would get a common denominator of 4, and I have to multiply the second fraction by 2 over 2. When I do that, I would end up with 3 pi over 4. If you need to write out the in-between step where you do pi over 4 plus 2 pi over 4 and then add it to get this, that's great. I am trying to keep this video a little bit shorter than, half hour. So then I take my pi over 2 here and I add pi over 2. So when I do that, I get 2 pi over 2. And then I can simplify that to be pi. My next row, I have 3 pi over 4. I'm going to add pi over 2 onto that. Again, I need common denominators. And then my last one, I have pi plus pi over 2. Now this time, I'm going to multiply my first term by 2 over 2. So I have 2 pi over 2 plus pi over 2, which would be 3 pi over 2. So to graph this curve, I'm going to scoot this up a little. I got to go a little bit further. It was a cosine graph, so I am going to add in my scale here. And I'm just going to go up to about 3 because my amplitude is 1 and I do not have a vertical shift, so I'm not going up or down at all. But I think a scale up to 3 is good. So I'm going to start with my original cosine curve. So I have my original curve, and now I want to take all of my x values and I want to shift them to all of these x values, because these x values are taking into account the period change and the phase shift. So let's start with that. It's going to be really hard because you can't see the top of my paper, but hopefully you have it on yours. And then I'll just scoot it every time. So for the first one, my point that was at 0, that was originally at 0, is getting shifted all the way to pi over 2. So looking at my graph, the point that's at a y value of 0, x value of 0, y value of 1, is getting shifted to pi over 2. So this point is getting shifted to about here. So I'm going to go back up to my table, and I'm going to check that off my list. I'm going to move on to my next row. So pi over 2 is getting shifted all the way to 3 pi over 4. So pi over 2, 3 pi over 4 is right there. Oh, you didn't see that. So this was pi over 2, and I shifted over to 3 pi over 4. I checked that off my list. Then my third point started at pi, and it is getting shifted to pi, so it's not moving. So on my graph, this point right here is going to stay. I'm just going to do it in a blue color so I remember to connect that dot. I'm going to check it off my list. Then I have, I think I can do this. Then I have 3 pi over 2. So 3 pi over 2 is getting shifted all the way to 5 pi over 4. So 3 pi over 2 is right here. and then it's on the x-axis. It's getting shifted to 5 pi over 4, which is on the x-axis, so it stays on the x-axis there. Check that off my list. And then the last row, my point that's at 2 pi is getting shifted to 3 pi over 2. So 2 pi is this one, and it's getting shifted over to 3 pi over 2, so about here. That might not be the most even. So this is my cosine curve after we did the period change and the phase shift. So if we want to make a note here, you don't have to do this, but I'm going to do it for the sake of the notes. And we can tell that there's a period change and a phase shift because a period change affects if it's being squished or stretched horizontally, and this was being squished. If we had squished it without a phase shift, it would get squished, and this point would still end up here. But because we squished it and we shifted it over for our phase shift, that's why it's in the middle. So we kind of skipped an in-between step by using or utilizing our table. So at the top, I just want to double check a couple things. We graphed using our period change here, which took into account our k, which was that 2. We also used our phase shift and graphed based on that, which took into account this value. The only thing we haven't done yet is this negative. So our amplitude is 1, we don't have to change that, but a negative means that there is a reflection over the x-axis, so I do want to reflect that on my graph. So what I'm going to do is I'm going to take my most recent one, which is the blue one, and anything that's above the x-axis, I'm going to flip to the below the x-axis. So this point is at positive 1. I'm going to flip it down to negative 1, but I keep it at that pi over 2x value. This point here is on the x-axis, so I keep it on the x-axis. This point is at negative 1, so I'm going to flip it, and it ends up at positive 1. The next point on the blue curve will stay on the x-axis, and the last point is at positive 1, so it is getting reflected to negative 1. So for my final curve, after we applied all of our transformations, is this red one, and it is our final. We are going to look at example 4, so I'm going to go ahead and flip my packet over. This equation does have every single transformation, not every single one doesn't have a reflection, but it has everything else. So we do want to go through this because there's a lot going on. So we have y equals 2 cosine of 1/2 parentheses x plus 3 pi over 2 parentheses plus 4. So it's ordered how I would like. So I have a plus 4 at the end instead of in the beginning. I have a number in front of my parentheses, and the number in front of x here is an invisible 1, which is good. That's what I want. So I can identify a couple things. I know that this is my a, and I know this is my k. This right here would be our b, and then this is our d, which is our vertical shift. So I have 1, 2, 3, 4 transformations that are happening. Doing this table only takes care of 2 of them. So let's get started so this video isn't too long. I'm dividing each of them by k, so I'm going to divide by 1/2. Well, if I divide by a fraction, that is the same thing as multiplying by its reciprocal, so I can multiply by 2. Multiplying by 2 is a lot easier, so that's what I'm going to do. 0 times 2 is 0. Pi over 2 times 2, well, my 2's will end up canceling, so I'd be left with just pi. Pi times 2 is 2 pi. 3 pi over 2 times 2, again, my 2's will end up canceling because technically it's 2 over 1, so then it'll go away, and then, oops, 2 pi times 2 is 4 pi. So I have my new x values to reflect the period change. I then want to take these and apply the phase shift as well. So I need to add or subtract my b. Well, if I know that it's a plus, it's actually going to the left, which means I am going to subtract 3 pi over 2 from everything. And then again, if this is a fraction, I want to make sure that my denominators are the same so I can do that operation. So 0 minus 3 pi over 2, that would just end up being a negative 3 pi over 2 because 0 minus anything is the negative version of that thing. Then I'm going to use this pi. I always use the most recent x value. I don't want to start with the original. So I have pi minus 3 pi over 2. When I make common denominators, I would multiply this by 2 over 2. I would get negative pi over 2. Then I have 2 pi minus 3 pi over 2. I need some common denominators. When I simplify that, it would end up being 4 pi over 2 minus 3 pi over 2, which would be 1 pi over 2. In my common denominators, I get 3 pi over 2. Last one is 5 pi over 2. I didn't talk through that a lot because I think the main part is the graphing. So I do want to start with my original curve. This is still cosine, so I'm going to do original cosine curve, and then I'll go from there. So in my graph, it is a little different, so I want to be careful. I know cosine starts at 1. So I can plot this kind of quickly. Whoops. That doesn't look great, but that's okay. This is my original. Now I'm going to graph using my table. So I'm not going to keep going up, back, and forth, but I'm going to take all of my original x values and I'm going to transition them to these x values because it takes into account the period change and the phase shift. So all of these are what I'm going to be using. So my first one is 0 is getting shifted to negative 3 pi over 2. So this point that is at 0 is getting shifted to negative 3 pi over 2. Then I have the point that's at pi over 2 is getting shifted to negative pi over 2, which is right there. The point that's at pi is getting shifted to pi over 2. 3 pi over 2 is getting shifted to 3 pi over 2, so it's staying there. And then the point that's at 2 pi is getting shifted to 5 pi over 2. So that's like stage 2. We have our original, we have stage 2. We still have other things to do, and I'm going to show you why in a second. But we can see that it was stretched horizontally and it was shifted over to the left. So we do have that period change, that horizontal stretch, and then our phase shift when it just shifted to the left. So if we go back up to our original, what we have done so far is we have taken into account our k by utilizing the middle of our table, and we have taken into account our b by utilizing this column in our table. So we still have our amplitude of 2, and we have our vertical shift of 4. So I'm going to do the amplitude of 2 and the vertical shift in 2 separate steps. So my amplitude of 2, we've practiced this before. I am going to take this value. The y value is 1. I multiply that by 2, so it should end up at a y value of 2. This has a y value of 0. If I multiply 0 by 2, it still is at 0, so I don't move it. Negative 1 times 2 is negative 2. So you can see they're getting stretched, and then this one will end up here. So when I do my amplitude of 2, it gets a little bit taller. And I'm going to make some notes on the side here. So for phase 2 in the blue, that was our period change and our phase shift. For the red one, which was our third graph, we changed the amplitude. And then we should add that our gold one is our original. So we have one more thing we need to do. So back up at the top, I'm going to check off my amplitude change of 2. So we still have to apply this +4 vertical shift. So I'm going to use a different color. Let's do purple. So that means every point is moving up 4. And I want to use my most recent, which is my red one. So in my red graph, I take every point and I go up 1, 2, 3, 4. This point, 1, 2, 3, 4. This point, 1, 2, 3, 4. 1, 2, 3, 4. And again, I'm only using the red one because it is my most recent. Okay, it doesn't look purple on the camera, but. So for my final cosine curve, we did the vertical shift, which is also our last transformation, so it is our final. So I did add it to the list here, and this purple one. And so if you don't need to graph the blue or the red, or you don't need to do all the in-between stuff, that is totally fine. I like to do it. It helps me stay organized to remember what transformations I have applied to my graph and which ones I haven't. But there's our final graph.